Welcome to the Cisco Prime Infrastructure 3.0 Product Training Series. This is the Device Management Overview video. Network operations require you to perform various tasks to manage network devices, their configurations, and their capabilities. For example, enabling devices with new technologies is a key activity to help the network keep pace with customer demands. As the organization expands, you might need to deploy a new branch or new devices on a campus. And you need to perform the ongoing management of device software images to address maintenance releases, security updates, or new technologies. Prime Infrastructure supports these activities by providing device configuration processes and archiving functions that help ensure flexible and efficient device configuration while retaining previous configurations for rollback and troubleshooting activities. Automated device deployment that compresses deployment timelines, expediting the time it takes for devices or locations to become operational. A straightforward upgrade process that includes upgrade analysis and image validation before distribution occurs to help avoid disrupting device or network operations. Training objectives. After you complete this training, you will be able to recognize the concepts and high-level processes associated with the configuration archive, configuring devices, deploying devices, and upgrading device software images. The configuration archive is an important factor in best practice device management. By providing the method by which you can review and compare configuration changes and perform configuration rollback and troubleshooting activities, the configuration archive supports ensuring that network devices are running their correct and optimal configurations. Let's take a closer look. Prime Infrastructure automatically collects and archives current device configurations after the device discovery process or after adding new devices to the network. This action ensures that there is an archive available of the current device configuration. And before deploying a new configuration to a device, it is an important best practice to archive that device's current configuration. This way, you know that you have a backup in case of a deployment failure. Then, if it becomes necessary, you can revert or roll back to the previous operational configuration, which helps avoid network disruption. And when you have successfully deployed a new configuration, we recommend that you archive the currently running configuration also. This action supports such activities as correcting startup to running configuration mismatches. We'll discuss configuration mismatches in more detail later in this video. Administrators can configure the device and archive settings that control archive functions. When administrators configure devices to report configuration changes as events in Prime Infrastructure, the system automatically archives those devices' current configurations when configuration changes occur. By configuring device event reporting, administrators automate the archiving process, which helps ensure that you have recent versions of a configuration available. Administrators can also define the number of device configurations that the system will retain and the time period for which it retains them in the archive before deleting them automatically. Also keep in mind that the maximum number of configurations that the system archives is a rolling amount, which means when archiving, the system retains the most recent archive and deletes the oldest archive. There are other administrative settings that control the behavior of the configuration archive. Ensure that you're familiar with archive behaviors before you begin working with device configurations to help avoid network disruptions. Now that you better understand how the system archives device configurations and the best practices to follow, let's look at the configuration archive and associated tasks in Prime Infrastructure. You can access the configuration archive on the Inventory menu. The system opens the Devices tab by default, which lists the network devices and their last configuration dates, and provides access to configuration details. When devices do not have archived configurations, the device name does not provide a link. You can filter the list to display specific groups or types of devices by using the navigation in the Groups list. When you need to archive a configuration in support of device configuration activities, you can archive it on demand or schedule the archive. You need to find and select the device with the configuration that you need to archive, and then click the Schedule Archive button. In the Schedule Configuration Archive dialog box, select a start time of now to initiate the archive process immediately. You can also schedule an archive to occur at a later time or to recur on a regular basis. For example, you might want to schedule the archive to occur during less busy hours to avoid causing traffic congestion. Or you might want to schedule the system to archive critical device configurations nightly in case the system does not receive configuration change events. You can track configuration archive activities in administration on the Job dashboard. The system indicates the job status and, when completed, whether the process was successful. Keep in mind that when you or others schedule an archive for a group of devices and system users add devices to that group after the archive occurs, the system will not archive those device configurations. When you need to see more details about a device's archived configurations or evaluate a device's startup or running configuration, click the Device Name link. The system opens the Configuration Archive Details page for that device and lists the configurations available in the archive. You can expand a configuration entry to review the details of that specific archive. For example, you can see the device's running configuration and, when applicable, its startup or VLAN configuration. When there is no difference between the startup and running configurations, there is no active link available under the Startup Configuration heading. Click a Configurations Details link. To see the device's configuration, you can review the processed configuration, which organizes the data in configuration sections, or the raw configuration. You can compare the device's startup or running configuration versions to determine the changes that occurred between versions. You can also compare the configurations to those of other devices when you're trying to identify differences among them. Performing comparisons supports activities such as evaluating configuration changes or troubleshooting. For example, archive comparisons help you determine the actions that you need to take to correct a configuration error. Archive comparisons also detect configuration mismatches when a device's startup configuration does not match its running configuration. Mismatches can be problematic because when the running configuration does not match the startup configuration and the system reboots, it will apply the startup configuration to the device rather than the running configuration. Let's look at correcting a configuration mismatch. When the system detects that a device's startup and running configurations do not match, the device list indicates yes in the Startup Running Mismatch column. To evaluate a mismatch, click the device's name link. Then, on the Details page, in the Startup Running Mismatch field, click the Yes link. The Configuration Comparison dialog box opens and displays the Startup and Running Configuration columns beside each other for easier comparison. In the Configlets list, the system selects Difference Only by default to make the changes easier to evaluate. The system also applies color coding to the text in the Running Configuration section to indicate details that have been added, updated, deleted, or are the same as the startup configuration. You can compare changes in both the processed and raw configurations. To correct a mismatch, you close the dialog box and return to the list on the Devices tab. Select the row of the device that you need to correct. This action makes the Overwrite button available on the toolbar. Clicking Overwrite opens the Schedule Overwrite dialog box. The system selects the Archive After Overwrite checkbox by default. This action ensures that the running configuration that you are applying is collected in the archive. Then you can schedule when you want the overwrite process to occur. When the mismatch is corrected, the system removes the Yes indicator in the Startup Running Mismatch field. Now that you've overwritten the startup configuration with the running configuration, the device will apply the correct running configuration if a system or device reboot occurs. The system also provides a link to see the device's current running configuration details in the latest archive field. The archive also provides an Archives tab, which lists the device configurations that are available in the archive. Here you can perform rollback and tag editing actions on devices. A rollback is the process of returning a device's configuration to a previous version that's available in the archive. Events such as a device configuration deployment failure or unexpected device behavior after configuration deployment might require you to perform the rollback process. You can also apply tags to configurations in the archives so that system users can recognize their uses or other information about them more easily. For example, a tag might indicate that a particular configuration is compliant with business requirements. When tags are available, users can search the archives by typing tag text in the Tag Quick Filter field. As you can see, the Configuration Archive is a key management tool when you're addressing device configurations. By following best practice archiving processes, you can help ensure that any device configuration that users might need is available, which can help optimize device functionality and reduce operational downtime. After network devices have been added to the initial inventory, you can configure them by using prime infrastructure. For example, when you need to enable new technologies. The devices that you configure must be in a managed state and be synchronized with prime infrastructure so that the system can indicate what is currently on the device itself. Prime infrastructure provides two methods of configuring devices. You can change a configuration directly on a device, or you can use templates. Changing configurations directly on devices supports scenarios in which you're making minimal and straightforward changes on a single device. For example, you might have a single device on which you need to enable application visibility and control for application reporting purposes. The template method applies specific device features or technologies to devices. Templates help automate deployment and help ensure configuration consistency when you're configuring large numbers of devices with the same configuration. Let's begin by reviewing how to change configurations directly on devices. You can access and change a device's configuration on the Network Devices page, which you can access on various application menus. You can change configurations directly on the device for most device types. To change a configuration, click the device name link in the list. The device's configuration is available on the Configuration tab. The Features list includes all of the features that you can configure for that device, organized in categories. Note that the configuration changes that you can make differ based on what's available for the device model and software release. Enabling the application visibility and control feature on a device is an example of a straightforward configuration change. You can select the interfaces on which you want the feature active and then, on the toolbar, enable the feature. When you change a configuration directly on a device, the system automatically overwrites the startup configuration so that it matches the running configuration. Now, let's review the template method for making configuration changes. You access configuration templates by navigating to Features and Technologies on the Configuration menu. In the Templates list, the system organizes templates into related groups. In this training, we're focusing on the Features and Technologies and CLI templates, which you will use most often. We'll begin with Features and Technologies templates, which include wired and wireless features and technologies. Features and Technologies templates are model-based templates that provide the configuration details that are specific to the feature or technology. To generate a template with a configuration that you need to deploy, navigate to and select the template in the list. Note that as you configure the template, you do not have access to the template CLI configuration. In the deployment process, you have an opportunity to review the CLI code that corresponds to the template before deploying it to the designated devices. When you complete a template configuration and save it, the system stores the template with the name that you assigned it under the My Templates heading in the Templates list. The templates in the My Templates section are available to all system users. When you're ready to deploy the configuration, you navigate to the My Templates page, select the template, and then click the Deploy button. You select the devices to which you're deploying the configuration template. Then you can define specific configuration parameters on a device-by-device basis as needed. When you schedule configuration deployment, as with scheduling archive activities, you might want to schedule the configuration activity to occur during less busy hours to avoid traffic congestion. You can also schedule recurring deployments, which are very helpful in certain scenarios. For example, you might want to prioritize business-critical application support during operational hours, and then shift support to address backup processes at night. You can support these activities with two separate quality of service configurations. By scheduling the operational QoS configuration to deploy alternately with the backup QoS configuration daily, you help ensure that resources are available to best support the key process at the appropriate time. It's important to recognize that some Features and Technologies templates require you to apply shared policy objects in the template details in order for you to successfully save them for use. This requirement means that the shared policy objects that you need must be configured before you configure the template. Let's review shared policy objects. To configure shared policy objects, you navigate to the Shared Policy Objects page, which you access on the Configuration menu. Shared policy objects provide a method of dynamically organizing groups of device interfaces, IP addresses, or subnets, eliminating the need to apply values to the devices or on the network individually. The values that you can configure for a policy object vary based on the type of object that you are defining. Let's consider the example of configuring devices to support communication through a firewall. The configuration will allow routers to identify the internal and external device interfaces that need to communicate, the portions of the network that manage the traffic, and the applicable communication protocols. To deploy that configuration, you use the Policy Rules Zone-Based Firewall template. The template requires the shared policy objects that will define the firewall parameters, including the source and destination security zones, the source and destination IP addresses, and the security services. By configuring an IPv4 network object, you define the IP addresses or subnet masks that apply to the firewall. You use the security service shared policy object to define the protocols to use. And by configuring security zone shared policy objects, you define the rules that the system will use. For example, indicating particular keywords in the interface descriptions to identify the interfaces that the system needs to include in the security zone. With the shared policy objects for firewall communications configured, you can select them when adding the policy rules to the zone-based firewall template. Now let's look at the uses of CLI templates and how they differ from Features and Technologies templates. CLI templates provide a method of deploying elements of device configuration not available in the Features and Technologies templates. CLI templates contain code that Cisco has predefined based on the type of configuration that you need. You can review the code in the CLI Content view or in the Form view. You can deploy these templates as they're configured or, when necessary, make changes to the CLI code, which is available for editing. For example, in the radius configuration iOS template, you can script by using the Apache Velocity template language, as indicated by the lines that begin with the hash symbol. You also add, edit, or remove variables in the CLI code by clicking the Manage Variables button. In the Managed Variables dialog box, you can make the changes that you need. It's important to note that CLI templates do not provide syntax analysis before you deploy them. That means that you can deploy CLI code regardless of its validity. If the code is not valid, the system will not execute the deployment successfully. Cisco recommends that when you change CLI templates, you also validate those changes by using input parameter validation. You can expand the variable entry that you're editing and enter a validation expression to help ensure proper template deployment. You can also write new CLI templates to support business needs. As with features and technologies templates, when you save a CLI template, it becomes available under the My Templates heading. In addition to the features and technologies and CLI templates, Prime Infrastructure provides composite templates. By configuring composite templates, you can group multiple configuration templates and deploy them to devices in a single action, which helps reduce deployment timelines. Prime Infrastructure also provides functions for you to configure lightweight and autonomous access point templates. To further expedite deployment processes, the system provides configuration groups, which are accessible on the configuration menu. You can organize configuration groups when you have a series of templates that you need to deploy to groups of devices. The system provides a wizard to step you through the process. Controller configuration groups is a similar feature, also accessible on the configuration menu, that supports wireless LAN controller configuration deployments. When you add a group, you assign that group a mobility group name and then include controllers and templates as needed. When configuring controller groups, controllers can only belong to a single group. If you add another group and include a controller currently assigned to a group, the system moves the controller to the group that you're adding and removes it from the previous group. Now that you recognize some of the templates and configuration support features that Prime Infrastructure provides, let's take a closer look at configuration deployment processes. When you deploy configuration templates, you can indicate the actions that you want the system to take during the process, including whether deployment continues in the event of failure, whether to copy the new running configuration to the startup configuration, and that when deployment is complete, whether the system archives the newly deployed configuration. When you deploy access point configurations, the process differs slightly based on whether you're deploying them to lightweight or autonomous access points. When you deploy lightweight access point configurations, the system deploys the device configuration to the controller that manages the access points, which then delivers the configuration to each access point. When you deploy autonomous access point configurations, which are CLI-based templates, the system deploys the configuration to each access point directly. Keep in mind that when you're deploying a template to a large number of devices, Cisco recommends that you deploy to a single device and test the configuration before deploying it to the rest of the devices. This process helps ensure that the configuration is valid and behaving as expected, and helps avoid large-scale deployment issues or failures. When you deploy a template or schedule it for deployment, the system generates a job, which appears on the Job Dashboard page in Administration. As the system executes the job, you can monitor it during the deployment process. To review configuration changes and archived configurations, you can navigate to the Network Devices page and open the detailed information for the newly configured device. Current configuration information is available on the Configuration tab, which is where you can also change the configuration directly on the device, as you saw previously. On the Configuration Archive tab, you can see the list of archives available for the device. As you can see, Prime Infrastructure provides effective methods for deploying device configurations. In the case of larger-scale deployments, templates provide a method that compresses the deployment timeline and helps ensure configuration consistency among devices. And when straightforward changes to single devices need to occur, you have access to edit most devices' configuration details. When configuring devices, always follow best practices to help ensure optimized deployment processes and minimize failures. Prime Infrastructure meets the demands of expansion, such as deploying a new branch or campus to the network, by automating device deployment and connection in the form of the plug-and-play process. By using templates that integrate best practice configurations, system users with minimal knowledge of device configuration processes can perform these large-scale deployments. Prime Infrastructure uses two technologies to deploy devices: Cisco Network Services, or CNS, and next-generation plug-and-play using the Application Policy Infrastructure Controller Enterprise Module, or APIC-EM. Prime Infrastructure implements plug-and-play functionality by using the plug-and-play gateway, which differs based on the technology. When using CNS technology, the plug-and-play gateway can be an independent installation, or it can be integrated in the Prime Infrastructure platform on the Prime Infrastructure server. When using APIC-EM technology, the APIC-EM assumes the role of the plug-and-play gateway. The plug-and-play process performs initial configuration deployment by: Step 1. Pre-deploying the device in Prime Infrastructure by configuring a plug-and-play profile. Step 2. Installing the physical device on the network. Step 3. On installation, deploying the bootstrap configuration that the profile contains. Step 4. By using the bootstrap configuration, the device connects to the network and requests its configuration through the plug-and-play gateway. Step 5. The system then provides the configuration based on the technology. Step 6. The configuration is loaded on the device. At this point, Prime Infrastructure adds the device to its inventory and begins managing it. Let's look at using plug-and-play profiles to deploy and configure new devices in Prime Infrastructure, which you access on the Configuration menu. Plug-and-play profiles are data structures that contain the bootstrap and device configurations, which are CLI templates. You also have the option to deploy a software image to the device during the process, which avoids the need to complete the software image upgrade process separately. To begin, you indicate the Bootstrap template, which provides device connectivity to the network and allows the plug-and-play agent embedded in the operating system to communicate with the plug-and-play gateway. Because the Bootstrap template differs based on whether you're using the CNS or APIC-EM technology, Prime Infrastructure provides example templates for your reference. Next, you indicate the configuration template, which provides the configuration that you want to have on the device when the plug-and-play process is completed. To add or edit this information, click the Device Details for Profile button. In the Device Provisioning Profiles dialog box, you can add more devices and details, or select and edit each device to add provisioning parameters. In the dialog box, you indicate the device identifier, such as a serial number or the device type. Then you indicate the specific parameters that you need to include in the Bootstrap and configuration templates that will configure the device. At this point, you also need to indicate the SNMP and Telnet SSH credentials so that Prime Infrastructure can manage the device. With the profile complete, you can deploy the profile, which pre-provisions the device or devices. On deployment, the plug-and-play gateway or APIC-EM waits for the device to contact it and presents its identifier and its device type. By using the Bootstrap configuration, the device sends the request to the gateway or APIC-EM and presents its identifier. On receiving the identifier, the system determines whether the identifier matches the profile. When the identifier matches, the system deploys the configuration template to the device. You can review the status of the profile deployment on the P&P status page. You can also see whether the profile successfully matched the device type or device identifier that you used. By using plug-and-play profiles in initial device deployment situations, Prime Infrastructure reduces deployment timelines significantly and helps ensure consistent device configuration during the process. In ongoing device management, you often need to upgrade device software images in support of such events as security updates and minor software releases, or to update devices to support new technologies. You perform upgrades on the Software Images page, accessible on the Inventory menu. Let's review the high-level upgrade process, which includes having the software images available in Prime Infrastructure, distributing software images from Prime Infrastructure to devices, and performing an optional upgrade analysis before distribution to help determine whether the devices are able to receive the upgrade. To begin, the images that you need must be available in Prime Infrastructure. When you need to import image files, you can obtain them from a variety of sources, such as from other devices or from a file available on an accessible server. Depending on the image source that you select, the Collection Options page provides the navigation that you need to find and select the image file. You can schedule image imports to occur immediately or at a later time. For example, when you schedule the import of a large number of images, or determine that the network is experiencing significant activity, you can schedule the import to occur at a less busy time. When you import an image manually, you can also define minimum distribution parameters in the image details, which you access by clicking the File Name link. By defining the memory size, flash size, and the boot ROM version, you can help ensure that image distribution occurs successfully. When you perform upgrade analysis of the imported image with other images available in Prime Infrastructure, the system uses these parameters to evaluate device preparedness for the upgrade. Before you start the device upgrade, you can perform an upgrade analysis to evaluate image compatibility and device preparedness. To begin, you select the image location, the devices that you want to upgrade, and the image that you are deploying to them. When you start analysis, the system validates and reports whether the device or devices can accept the upgrade and whether the system can install the image on those devices. To perform image distribution, the system validates that the network devices contain sufficient storage and memory, whether the images on the devices are newer than the image that you are installing, and whether the image that you are installing is already installed on the devices. To initiate image distribution, select the image and open the Distribute Images dialog box. The dialog box provides a wizard that steps you through the process. Note that when you perform the image deployment step, you can configure the device or devices to reboot when the upgrade is complete. In situations in which you are upgrading a large number of devices, Cisco recommends that you upgrade a minimal number of devices first and validate that the upgrade is successful without rebooting them. Then you can schedule the upgrade for the rest of the devices and reboot them automatically on successful distribution. This way, you can help ensure successful deployment and avoid rebooting each device manually, which can be a time-consuming process. Administrators can configure global settings that define system behaviors during and after the image distribution process. Some of the key settings include whether the system inserts the appropriate boot command automatically. As you saw previously, when determining whether devices reboot automatically, the user scheduling an upgrade can override the global setting as needed. Whether the system only recommends images that contain the same feature set as that of the current running image on the device. and requiring the system to use a secure protocol for image distribution when a secure protocol is available. When the distribution executes, the system generates a job that you can monitor on the Job Dashboard page in Administration. In the User Jobs list, you open the Software Image Distribution page. The job appears as pending until it starts, and updates the status to running when it starts. Note that the job takes time to complete based on its size or other factors. When it starts, additional time can pass before the job status changes. You can also refresh the page manually to ensure that you see current information. Performing device software image upgrades is an important ongoing device management process that helps ensure that devices are operating optimally. Training Summary. You completed the training. In this training, you learned to recognize the concepts and high-level processes associated with the configuration archive, including archive management best practices, configuring devices, including the direct change and template configuration processes, deploying devices, and upgrading device software images. This concludes the Device Management Overview video. Thank you for your interest and attention.